All right, here's the second page, you guys. It's a reasonably easy page. Our goal on here is finding the inverse of a linear function. I went and get myself a new highlighter. There, kind of a bit of a change from the yellow. And we're also going to do something else. We're not just going to find the inverse of a linear function, which we are definitely going to do. All right. We're going to check it. And we're going to check it two ways. All right. So to check the functions are inverses using composition. So we're going to check a composition, which is an algebraic method. We're also going to check it using the method we saw on the other side. We're going to see if the old function and the new functions are in fact reflections over the line y equals x. All right. Our steps are here. I'm going to read the step and then come down and do the step so you can see it one section at a time. All right, so the first step says substitute y for f of x. So here I go. I'm going to come down here. I'm going to take this f of x out, and I'm going to say y equals 3x plus 4. First step's done. All right. The next step says switch x and y. And the second I switch this x and y, it has in fact become an inverse. All right? It's just not a good format for an inverse. We're used to seeing things, step 3, solve for y. So I subtract 4, and I got x minus 4 equals 3y. That's 4 from both sides. I'll show this step divided by 3. I'm going to switch sides. I'm going to bring this over here. So 3y divided by 3 is y equals x divided by 3, right there, is 1/3 x. Negative 4 divided by 3 is negative 4/3. I'm going to go ahead and circle that. It is my hope that you can all see the slope and y-intercept in there. So I'm going to graph my original one with a y-intercept of 4. 1, 2, 3, 4. And I'll write this slope. My slope is 3/1. That means I can either go up 3 and right 1, or if I want, down 3 and left 1. That would be the same. And down 3, left 1 seems easier. 1, 2, 3, 1 over. I'm going to do it again. 1, 2, 3, 1 over. I'm going to do it one more time. 1, 2, 3, 1 over. And I get a line that looks like that. That was my original function, which is f of x. I'm going to write this a little different. I'm going to write it down here. I'm going to write this as f inverse of x. All right. And we've got our 1/3 x minus 4/3. So I'm going to find my best 4/3, and that's a negative 4/3. So it'd be down about 1 1/3. And that's a 1/3 x. So if I go down 1 and over 1, 2, 3, somewhere around there, I end up with a line. Let's give myself one more point. So 1/3 x is up 1 over 1, 2, 3, something like this. I should do that a little better than I just did. But I get a graph that looks more like that. And to me, this looks like a reflection. That would go there. So we're reflecting over this dotted line, which is in fact y equals x. So that's a good verbal check to make sure these are okay, but there's also a way to do it algebraically. All right. One thing inverse functions do is they undo each other. So, and I'm just going to show you, right? So if I came over here and I said, what is the f inverse of, let's try something that I know will work. -2. All right. Well, the f inverse of -2 is in fact -4. So this part would be replaced with -4, and I'd have f of -4. And f of -4 is -2. So you can see they undid each other. I actually ended up with exactly what I started with. It's almost like multiplying by 2 and then dividing by 2. These inverse functions undo themselves. All right. So I'm going to show you how that works. This time, I'm going to do this. I'm going to say, hey, I'm going to take my f function, into that f function, I'm going to turn my inverse function in of x. I'm going to see if I in fact get x. All right. So here's my f function. I'm going to write it without the x. So 3 plus 4. All right, we'll see if I get x. Check it out, right? See if it's x. I'll even write x over here. And I'm going to plug my inverse function in instead of the x that I took out right there. All right. My inverse function is 1/3 x minus 4/3. If I distribute that 3, I get x right there. And I also get -4 plus 4 equals x. These guys cancel, and I get x equals x, and it checks out algebraically as well. We're going to do one more together. So I'm going to come down here without the description, and I'm going to leave this third one for you guys. I'm going to highlight this. You should do C without me, but I'm going to go ahead and do B. All right. So doing the steps a little more quickly. I'll replace f of x with y. Y equals 2x minus 2. I switch x and y. X equals 2y minus 2. I solve for y. I add 2. X plus 2 equals 2y. Divide by 2. And I'm going to switch. I'm going to go y equals, let's go ahead and put it over here, 1/2 x if I divide x by 2, plus 1. I'm going to replace that y with f inverse of x, indicating that it is the inverse function of f of x. I'm going to circle it. I'm going to circle this original function. I'm going to graph them both to check them graphically. If I check them graphically, they should be on opposite sides of this the whole time, reflections of each other. So pointing up here, y-intercept of -2, slope of up 2 over 1, up 2 over 1, up 2 over 1, and I'm going to connect it. All right. Since they're reflections, I should get something that crosses here, right? Let's see if it happens. So this is 1/2 x plus 1. I'm going to go to 1. It's my y-intercept. My slope is up 1 over 2. Oh, look at that. Up 1 over 2. I'll help you soon, son. And it sure looks like they're reflections over this line y equals x. The last time we tested this, we should really do it both ways, but I'm using a lot of space. So we're going to do, instead of f of inverse, we're going to do f inverse of f of x. And no matter which way we do it, notice that I put the inverse in the root function. Now I'm putting the function in the inverse down here. We should still set x. So now I'm going to write this inverse function down here without my x. So here it is. 1/2, and my x is right there, plus 1. Let's see if it does equal x. All right. And I'm going to put the original function in, which is 2x minus 2. Let's see if it in fact equals x. I've kind of set this up. We don't have to do this equals x. We can just plug them in and see what happens. All right. So if I distribute through, I get x minus 1. 1/2 of 2x is x. 1/2 of -2 is -1 plus 1. And then these guys cancel out and I get x. All right. So I could say, normally people just set up the function like this and then state it. The f inverse of f of x equals to x, and that is a check. All right. So we have checked it graphically. We have checked it as an equation, graphically as an equation. And we found our functions, and it works out. So try this last one. Go through the steps up top, check it graphically, and then go ahead and check it algebraically. I will see you soon.